Welcome to Ask and Learn.
Okay, well, in this problem we have to repeat problem 18 using helium as the thermodynamic gas. So since between the process 4, 1, the process is isentropic or adiabatic if we prefer, we know that the transformation between the pressures in an isentropic transformation is just P1 equals P4 T1 T4 K divided by K minus 1. This is the definition of the transformation of the temperature. Sorry, this is the definition between the relation of temperature and pressure in an isentropic process. So we just need this, and we just need to remember that the maximum pressure in a Carnot cycle is described by the pressure 1. So this is going to be 300 1200 divided by 350 to the power of 1.667. This is we have to look in the book because we do not know the specific heat of the helium. So 0.67. Therefore we have a maximum pressure which is going to be 6524 kilopascal. So again, we just need two things to solve this first item. To look at the specific heat of helium and to remember the definition of the transformation of an isentropic transformation. So this is item A. Item A. Now item B. We have to find the input heat. And how we manage to do this? Well, again, we can use the Carnot, the efficiency, sorry. So the efficiency of any thermodynamic cycle is described by the network divided by the input heat. But since this is a Carnot cycle, this needs to be equal also a 1 minus TLTH. Therefore, the input heat is going to be equal 0.5 divided by 1 minus 350 1200. Calculating this, we find that the input heat is going to be 0.706 kilojoules. Okay, now for item C. For item C, we have to find the mass. We have to remember that the mass comes from the entropy. So we just need to remember that S4 minus S3 is going to be equal Cp natural log of T4 T3. Uh, let's see, minus R natural log of P4 divided by P3 that multiplies TH minus TL. Okay, therefore this is going to be equal the mass, the mass, as we know, is just the network divided by R natural log of P4 P3 that multiplies TH minus TL. And this is going to be equal M equals 2.0769 natural log of 300 divided by 150 1200 minus 350 50. All this is dividing 0.5. Therefore, the mass in this problem is going to be 4.09 times 10 to the minus 4 kilograms. And that's the final answer to this problem. Thanks for watching.